Hello, welcome back. Today we will going to discuss about deadlock. What is deadlock and how we can avoid it, and what are the CPU algorithm which we can follow to avoid the deadlock. So let us start with it. What is deadlock? Suppose there is one thread T1. It has lock a resource R1. Okay. Now thread 1 only release the R1 when its process get complete, and to complete that process it need another resource, that is R2. But the R2 is locked by the another thread T2, and T2 only release R2 when its process get complete, and T2 process only complete when it get R1. So in this situation, no thread will get the both the resource. So this situation is called deadlock. And this deadlock situation happened because of four main reasons. First one is mutual exclusive. What does it mean? It means that if one resource is R1 is needed by T1, so it can be locked by T1 so that no one can share that resource with T1. So it make this resource R1 a mutual exclusive, means locking that resource so that it can mutually use. Nobody can use that resource, due to which this deadlock situation happened. Second condition is hold and wait. Here what happened? T1 hold R1 and wait for R2. T2 hold R2 and wait for R1, due to which deadlock occur. Third one is circular condition. What is circular condition? In circular condition, what happened there? T1 hold something and wait for other resource. T2 hold that resource and wait for other resource. T3 hold something and wait for T1 resource. Now this is become the circular condition and no one can complete their work. This is called a circular condition of deadlock. Next one is no preemptive. What is mean? It does mean that suppose T2 want to complete this work. It has R2, but it cannot forcefully take R1 from T1. So there will be no forcefully taking resource from any other thread, due to which deadlock occur. So there are four main reasons why the deadlock occur. Let us see how we can avoid it. So let's start with the first one, that is mutual exclusive. Mutual exclusive. So avoid mutual exclusive, we can do two things. First thing, we don't use lock in read resource, read only resource. Why we use lock? We use lock that in critical section some other thread cannot come and change the resource. But if there is a resource which has to only a read condition, why we need the lock? So we can't use lock in a read only resource, then mutual exclusive can be avoided. Second, we do not use lock on shareable resource. A resource which is shareable, we can easily share with the other thread. We do not use the lock. If we use the lock, it will become the mutual exclusive of one thread. So to avoid that, we do not use lock on a shareable resource. Next one is circular condition. So in circular condition, what happens? Suppose T1 and T2 are two threads. It needs resource R1, R2. It also needs resource R1 and R2. So what will happen? T1 occupy R1, T2 occupy R2. Now T1 wait for R2 and T2 wait for R2. So T1 wait for R2 and T2 wait for R1. Now it becomes a circular condition. So to avoid this circular condition, what we do? Every thread take the resource in a order manner. So what will happen? T2 only take the resource first R1 then R2. T2 only take the resource R1 then R2. What will happen? Whoever take the R1 first will take R2 first. Whoever then T2 take the R1 and then it take the R2. Then there will be a no circular condition. What is mean? That suppose T1 take R1 first. Now T2 do not have R1. So when the R1 work then T2 will be R2 will be taken by T1. After this, T2 will take R1 and R2. So if the resources are taken in a other manner, there will be a no deadlock situation occur. Next one is no preemptive. So to avoid no preemptive deadlock condition, what we take, if suppose T1 hold R1 and want R2, but R2 is held by T2. So what will happen? T2 first release R1, okay, then try to acquire both of them at the same time. Why it is happen? Suppose T1 need two resources R1 and R2. T2 need two resources R1 and R2. So both of them try to acquire both of these resources at the same time. Same time when they need it. Suppose T1 has a R1 and its work get completed. Now it need R2, and T2 also need R2 and R1. So what will happen? They try to acquire both of them at the same time. So which one will get both of them first complete the work and then it give to the other thread. But there will be a problem. Suppose T1 also want R1 and R2, T2 also want R1 and R2. Now both wanted the same resource at the same time. So which one will be taken? Whom to give R1 and R2? This condition becomes live lock condition because no one can acquire if at the same time both of them want the same resource. So no one can get. So to avoid this, we will request to add a time frame of difference. Suppose T1 try to acquire the both of them at a 1 second, T2 acquire at a 2 second. So by this, each one can acquire both the resource at a same time, at a different time, but both can complete their work. Another one is hold and wait. Hold and wait can be done with the two different ways. First one is no preemptive way. So similarly to no preemptive techniques, we will try to acquire both of them lock when they are needed, just like a preemptive way. But another thing we can do is we are trying to acquire all the resources at the beginning. So suppose T1 needs R1 and R2. So when T1 starts its execution, it tries to acquire both the log at the beginning. But there will be problem here. Suppose T1 needs R1 and R2, but R1 is needed at 1 second, R2 is needed at 10 seconds. So there will be 9 second wastage of R2 resource because at that time any other thread can acquire this resource and complete its work. So this acquiring at beginning does not work properly in a hold and wait. So in mainly no preemptive way, which we use in the no preemptive, is same way is used in hold and wait condition. But how the CPU schedule the different algorithm so that it avoid a condition of deadlock. So CPU schedule, how the CPU schedule the thread to avoid the condition of deadlock. So there are two different ways. First one is safe state. Safe state of scheduling is that scheduling state in which there will be a no deadlock occur. Unsafe state is that state in which probability of occurring the deadlock is happen. Okay. So to avoid this, CPU schedule the algorithm thread in such a way that there will be a no deadlock condition occur. How will it happen? Suppose there will be two resources R1 and R2. There will be a fourth thread T1, T2, T3 and T4. T1 need both of them. T2 need both of them. T3 need this and T4 need none of them. Okay. So how will CPU schedule if there will be two processes can run simultaneously? So what will CPU do? CPU can't run T1 and T2 simultaneously. Why? Because both of them need the same resource. So CPU can run T1 and T2 and a parallel way. But T3 can be run with T1 or T2 in either of them. Why? Because when T1 use R1, then T2 can use R2, and when T2 use R2, then T2 does not need it, T3 does not need it. So during T1, T3 can work simultaneously, and T4 does not need anything, so it can run after T3. By this way, we can schedule the algorithm. Let's take one more example. Suppose there will be a thread T1, T2, T3, T4, two resource R1 and R2. Now this is a way. T1, T2, T3 require all the resources and T4 require none. So if there will be two CPU, 1 and 2. So now T1, T2, T3, none of them can run parallelly. So they can run only series way, and T4 run anytime because it does not need. I hope with this you will understand what is deadlock, where we use it, how we avoid the deadlock condition, each and everything. We will meet in the next video to take deeper dive about other topic in operating system. Till then, goodbye.